Ever wondered what makes your car, well, your car? It's not just the engine or the paint job. No, deep inside there's a hidden world of memory chips that hold its unique identity. So today, let's pop the hood on your car's secret memory. Okay, so at the very heart of your vehicle, you've got the engine control unit, or ECU. The easiest way to think about it is as the car's brain, right? It manages pretty much everything from fuel injection to engine timing, making sure everything runs just right. But it also holds the car's digital DNA. So what happens if that brain gets fried? It's a really high-stakes problem. You can't just run out and swap in a new one from another car. And why not? Because that ECU holds all that unique data, and if you lose it, it's like the car gets total amnesia. And look, we're not talking about your radio presets or your seat position. This is the absolutely critical stuff. The vehicle identification number, the security codes that let your key start the engine, all the custom settings that keep it running perfectly. Without this data, your car is basically a very, very expensive paperweight. So who are the keepers of all this vital information? Well, they're these tiny little memory chips soldered right onto the ECU's circuit board. They are the true unsung heroes here, and understanding them is the key to solving our whole car amnesia problem. The star of our show today is a chip with a name that is a real mouthful. EEPROM. It stands for Electrically Erasable Programmable Read-Only Memory. Yeah, I know, but it's a super special kind of memory, and it's designed for a very specific and very important job inside that ECU. Now, you've probably heard of EEPROM's more famous cousin, flash memory. That's the stuff that's in your phone, your USB drives, it's everywhere. The most important thing they have in common is that they are both what we call non-volatile. And all that means is they hold on to their data even when the power is off. For a car, that's absolutely crucial. So if they both remember data without power, are they basically the same thing? Nope, not even close. And this is where things get really fascinating. We're going to put them head-to-head to see why engineers choose one over the other for certain jobs. The difference really comes down to their most basic building blocks. You can kind of think of it like this. An EEPROM memory cell has 2 transistors, almost like a built-in backup system. A flash cell only has 1. That 2-gate structure makes EEPROM way more robust and gives it some unique abilities, but it also makes it more expensive to produce. And here's where you can really see those trade-offs in action. Just look at endurance. EEPROM can be rewritten about 1 million times. That's way more than flash. But the biggest difference is how they erase data. EEPROM can change a single tiny byte. Flash has to erase an entire massive block. That difference is everything when it comes to speed and precision. 1 million cycles. Just let that sink in. That is incredible durability. It's perfect for data that might need to be updated here and there over the entire lifetime of the car, like performance settings that adapt as the engine ages. And it's not just durable. It is surgically fast for those tiny changes. Erasing and rewriting a single byte takes about 5 milliseconds. That's practically instant. Now compare that to Flash, which can take several minutes just to erase a block before it can even start to write new data. It's the difference between a quick tweak and a major operation. And this quote right here sums it all up perfectly. EEPROM gives you precision. If a mechanic just needs to update the VIN number, they can do it in a flash. With flash memory, you'd have to use a sledgehammer, erasing this huge chunk of data just to change one tiny little part. It's just not efficient for that kind of job. Okay, so how does all this techie stuff help us with our original problem? Remember that broken ECU? Well, with this knowledge, a skilled technician can perform what is essentially a brain transplant for your car. They use this really cool tool called an EEPROM programmer. This device lets them connect directly to that little memory chip, read all of that critical data, the VIN, the immobilizer codes, everything, and save it as a backup file. Then they can take a new ECU and write that exact same data onto its chip. Boom, you've just cloned the car's brain. Now, a technician has a couple of ways to do this. They can try to go through the car's diagnostic port, the OBD2 port. That's the fast and safe way. But sometimes car manufacturers put in security that blocks this. The other way is called bench mode. That's where they actually take the ECU out, pop it open, and connect right to the chip. It takes more skill, but it gives them total control.
The process itself has to be done with extreme care. You gotta find the exact right chip on the board, use the correct voltage because the wrong one will fry it instantly, and most importantly, you have to read and then verify the backup file is good before you even think about writing it to the new ECU. One little mistake here can be catastrophic.
So when you really put it all together, the EEPROM emerges as this incredible, unsung hero of your car's electronics. It's not the biggest memory chip, it's not the cheapest, but it is purpose-built for its vital role. So let's recap why it's so perfect. Its high endurance means it's reliable for the entire life of the car. Its ability to change single bytes makes it super efficient for updating specific codes. And its small size is actually a feature, not a bug. It's not for storing giant files, it's for protecting small, absolutely priceless pieces of data. It's a specialist. So what's the big picture here? What should you take away from all this? First, all technology is about trade-offs. EEPROM trades big capacity and low cost for incredible endurance and precision. Second, it shows us that EEPROM is the specialist, the surgeon, while Flash is the generalist that handles the heavy lifting. And finally, choosing the right tool for the job is what makes all of our modern devices work so well. And that kind of leaves us with one final thought. We've uncovered this secret memory inside your car. But as all of our devices get smarter, from coffee makers to thermostats, you have to wonder, what other hidden, specialized memories are working silently in the background, keeping our whole digital world alive?